All right. Good morning, guys. Who's all here? Let me know. Say hi in the chat. All right. We'll get started in a couple minutes. Just letting a couple more people sign on. What's going on, Haley? What's up, Jose? Hey, Daisy. Be right back. Oh. Okay, that's a little better. It's a little more bright. Man, how you guys doing? I'm kind of liking this teach from my couch type of thing. It's cool. I don't have to wake up too early. It's nice. You guys get to do class from your bed or your couch. All right. Okay. Okay. All right. Well, I'm gonna get started. If anybody tunes in a little later, just feel free to kind of rewind and then watch at your own pace. Okay. So today, new unit. I'm pretty sure we're on notes 34. I don't remember. Is it 34 or 35? Can you tell me, Haley or Daisy? I know your notes are usually pretty organized. Yes, no, maybe. Okay. Well, I guess for now, I'll keep it at 34. I think it is. If not, I'll just go back and change it later. All right. So today, we get to start something new. So let me just kind of briefly guide you through where you can find everything. So I've already posted the foldable under Unit 6 folder on Schoology. So let's kind of navigate over there right now. Okay. All right. So you see right here under Unit 6, so I've split it up. So I left online week number 1. The only thing I put in there was the Toy Factory project tutorial. Okay, I think that's better just to keep that separate, and then everything else will stay in Unit 6. Okay, so for Unit 6, I broke it up into, there's the foldable already. So if you guys want to just like, most of the notes that I'm going to use for today come from the foldable. So if you want to do them on a notebook first and then just transfer them over, that's okay. You can do that. If you want to print the foldable out now, and then go ahead and just do it on the foldable. That works too. Okay, so then I split it up into homeworks, notes, and videos. Okay, so the notes will be the ones that I do like on Office. Okay, so the ones that I write, I'll PDF print those and I'll put them in there, and then I'll have the videos separate. Okay, so just so you have an idea of where to find everything. So the first homework is already there, so you can go ahead and work on that once we're done with this lesson. The problems are pretty easy, I think, not too many. And then the answers are down at the bottom, so you can double check your work. Okay, so that's pretty much it. All right, so let's go ahead and get started. Okay, 35, 34, 33. Okay, let's just go with 35. All right, I'm gonna change this real quick. I think it was 35. I think I gave out so many things I lost track. All right, so first thing about today, okay, is to really think about what an imaginary number really is. Okay, so an imaginary number is essentially part of all of the numbers that you can think of. Okay, but it's only a small part. Okay, so I'm gonna draw a diagram in the first box. So right now I have 6 boxes set up. So you could probably get away with maybe 8 boxes on the first page. Right now I have it at 6. Okay, so for this first box, the first thing I want to show you guys is where these numbers fit in terms of all of the other numbers that we know about. Okay, so the imaginary number comes from, you want to think of this bubble of numbers. Right, every single number lives inside this bubble. Okay, now the bubble basically has 2 parts to it. You have your real numbers, okay, and your real numbers are all the numbers that you've worked with up until now. It's your integers, it's your fractions, it's your decimals, it's pi, right? All of these numbers that you know of, they fit on that side of the bubble. Okay, so integers, we have rational numbers. Rational numbers are like fractions. Okay, you have your irrational numbers. Okay, so numbers that don't exist as fractions, but basically anything else, right? And then you have, for example, right, numbers such as pi, things like that. Okay, so anything that else you can write out as a decimal or fraction, right? Those are your real numbers. And then the other side of the bubble is something called the complex numbers. Okay, and the complex numbers is a set of numbers that we're going to take a look at later, actually the next lesson, and they come in the form a plus bi. Okay, a plus bi. Now a and b can be any number, but notice that right next to b there's an attachment there. There's the I. Right now the I is the thing that we're going to study specifically today. Okay, so within the complex numbers exists the imaginary numbers. Okay, so that's where the imaginary numbers fit in terms of every number that you know. You have your real numbers, which are completely separate from the complex numbers. The complex numbers have 2 parts, right? It's a connection here of a plus bi, right? So the complex numbers are stuck together, okay, with the plus sign in between, or sometimes it's a minus sign. The imaginary number specifically relates to the bi, okay, the one that has the I attached to it. Okay, and so today we're going to take a look at how you can basically deal with the I, how you can take it out of the negative, right? How you can take the negative outside of a square root, and then we'll see what we can do with it a little bit more. Okay, so that's just kind of a context, a little bit of a diagram for that. Okay, any questions about that so far? All right. So let me know if anything comes up. Okay, so let's move on to our first example. Okay, so again, I'm pulling these things out of the foldable. So if you're following along on the foldable, we're going to go to the number 2 tab. Okay, number 2 tab, I'm going to start up here. Okay, so some of the stuff that I'm going to write down exists on the foldable already, but I'm just going to go ahead and write it for those of you who can't print it just yet. Okay. All right. So what is I? Okay. So the number I okay is the basic element of the set of imaginary numbers. Okay, here's how we define it. Okay, now when I define something, that means that is exactly what it is, right? So I is equal to the square root of -1. Okay. Now from that, there's so much information that we can get just by knowing the definition of what I is, right? So I is equal to the square root of -1. Okay. Now I can do many things with this. Okay. So now that I know that I is equal to the square root of -1, then I can also then go ahead and now I can square this. Okay. I can square it and find out what I squared is. Okay. So now if I is equal to the square root of -1, if I were to take I squared, to the second power, right? It's the same thing as me saying the square root of -1 squared. Okay. Now, what do we know about square and square roots? They cancel each other out, right? So then we can say that these two eliminate. And so really the I squared is the same thing as -1. Okay. So I is equal to the square root of -1 and I squared is equal to -1. Okay. Okay. Now there's a cycle between these I's, right? They only go so far before they start to repeat themselves. Okay. So for example, here's what I mean. What if we thought about I to the third? Okay. I to the third. Would you agree that that's the same thing as saying I times I squared? Yeah, right? So I is the same thing as the square root of -1, and we just found out that I squared is the same thing as -1. Okay, so now if I multiply those things together, remember one of them is inside the square root, one of them is outside, right? The second -1, this one right here, this is not inside of a square root anymore, right? I squared, the square eliminated the square root, so it's literally just -1. So when I multiply these things together, well, I to the third is really going to be negative square root of -1. Okay? That right there is what I to the third is equal to. And then, now what if we take a look at I to the fourth? Okay? If I took a look at I to the fourth, would you agree that this is the same thing as saying I squared times I squared? Right? I can take that power of 4, split it up as I squared times I squared. Now, what's nice about it is that now I know since I squared is -1, and then I squared is also -1, well, what am I going to end up with here? That's going to be just a +1. Okay? So I have this cycle that I's go through, because now, right, think about what would happen next if I went I to the 5th. Okay? If I went back to I to the 5th, let's see what happens. Would you agree that I to the 5th is the same thing as saying I times I to the 4th? Okay, now what do you know about I to the fourth? I to the fourth is equal to 1. And I is just I, right? So then, in this case, I times 1, that's just I. And what do we know I is equal to? I is equal to the square root of -1. Okay, so notice how after, right, we went from square root of -1 to -1, negative square root of -1, positive 1, and now we're back to where we were at the first step, right? So take a look at this power right here, I to the 5th, right? It's the same thing as I. Same thing as square root of -1. And that's the same thing as what we had back here. Okay. What do you think I'm going to get if I try I to the 6th? Right? What's your guess? And now let's find out. Okay. If I tried I to the 6th, okay, would you agree that's the same thing as I squared times I to the 4th? Well, I to the 4th, isn't that just 1? And what do you know about I squared? Isn't I squared -1? So what are you getting? -1. Isn't that the same thing as I squared? Right, so you see it starts to cycle back. So there's only so many outputs you can get when you're dealing with I, right? After a while, they start to repeat each other, okay? After how many? Well, after you get to power of 4. After power of 4, right? Once you get to I to the 5th, that's the same as I. Once you get to I to the 6th, it's the same as I squared, right? So what's really happening is that after you get to the I to the 4th, it then cycles back, right? So 1, 2, 3, 4, it basically just resets itself, and then you're back to 1, then back to 2, then back to 3, then back to 4, then it resets, okay? So there's this cool, interesting component about I where you're kind of limited. There's only so many things you can get, and it's kind of cool because it something that doesn't happen in other types of math, okay? So we'll come back to this, but just want to let you know that we might use some of this a little bit later, okay? All right. So all this time, right, we've been running into, in box 3 now, we've been running into these types of problems, like especially when we were solving systems, and we got a square root inside of we got a negative inside of a square root. And then we would just stop because we would say, well, it's imaginary. That means that there's no real solution on our coordinate plane. We're going to leave it as imaginary, and then we're just going to move on, right? We didn't do anything else with that number besides just say imaginary or no real solution. Well, here's what you would normally do next. Okay, so now we can actually move it a little bit step further because now we can simplify a little bit further because we know what we can do with the I now, the power of having I. Okay, so just real quick example here for this first example. Let's start with the square root of -3. Okay, let's talk about how I comes into play here. Okay, so there's a property. Okay, there's a property with square roots that says if you have the square root of AB, right, the product of A times B, you can also list it as the square root of A times the square root of B, meaning you can split them apart as long as they each stay within their own square root. Okay, and it also works the other way around, right? So because it's an equal sign, it's a two-way street, right? If I have the square root of two numbers being multiplied together on the inside, I can split them apart. I can then also take two numbers that are split apart and combine them by multiplying them together on the inside. Okay, how does that work with example here with number 3? With example 1 is I know that the square root of -3, I can make that a product of two numbers. What is the product of those two numbers? I can make this the product of -1 times 3. Okay, now because I know that that product, -3 times 1, gives me -3, that's why I'm able to break it apart. And then following this property, I can then say, well, hey, this now equals square root of -1 times square root of 3. Okay. So now, what do we know about the square root of -1? Well, this is the same thing right here as I, right? That's I. And then I can bring down times the square root of 3, right? We don't need to simplify square root of 3. I don't need to turn that into a decimal. I'm going to leave it like that. Okay. Now, the only thing that needs to switch now is, remember when we talked about complex numbers? You see the convention? I have a number first, which is b, and then the I goes at the end. So the convention with imaginary numbers is always put the I at the end of the number. Okay. So then here, I just got to switch it around a little bit. I'm going to write square root of 3 first. Then I'm going to put a little tail because I'm going to close it. Right? I'm closing it, letting you know that 3 is the inside of the square root. The I is on the outside, completely outside of the square root. Okay, so now you have an I outside of the square root. Okay, that's why I put that little tail down on the root to let you know I is outside, not inside. Okay, and that's essentially what it allows you to do. Once you have I on the outside, then you can combine like terms. There's a whole nother list of things you can do. You can basically do the exact same things you do with real numbers. You can do them with complex numbers too. Okay, because now you've allowed yourself the flexibility by pulling out the I from the inside of the square root. Okay, and that's basically it. Okay, so think of all of the times that we ended up with like a negative inside of a square root. Now we could just rewrite them. Right, by pulling out the I, we pull out the I, and essentially that number goes back to being a positive. Okay. However, this still represents an imaginary number. Okay, the solution that you got. Okay, the fact that it has an I attached to it lets you know that it lives in the imaginary world and not the real world. Okay, not the real number world. Okay. So again, if any questions pop up, feel free to just put them on the chat, and I'll try to get back to it. Okay. All right, let's move on to another example here. Okay. All right, so let's try. Let me switch this. Okay, so example 2, we got the square root of -98. Okay, so a couple things we can do here. The first thing, get rid of your imaginary, right? You can break this up. You can see how this becomes the same thing as the square root of -1 times 98. Okay? Because of that, you can split it and say this is the square root of 98 times the square root of -1. Okay, well, the square root of 98, I'm going to deal with it later, but for now, I'm just going to bring it down. Square root of 98. And then the square root of -1, that's I, right? So then this becomes I. We put the I outside of the square root. Okay, now square root of 98 is not good enough for us anymore. We need to simplify this as much as possible. This is where factor trees come into play. Okay, we may have done this a little bit early on in the year, but we're going to spend more time with it, especially now in this unit. Okay, so what you need to do is simplify square root of 98 into the lowest factors possible. Okay, so you start with 98 and you think what numbers multiply to be 98. Right, so think about it. What could they be? All right. Well, remember that if a number ends in an even 2, 4, 6, 8, or 0, it's an even number. So at the very least, you can divide it by 2. Okay, so if you divide it by 2, then at least it helps. And then now you have a smaller number that you can then maybe look for factors of. So it could be 2 and 50. 49. Okay. All right. Now, do you see, right? Now 49, you can see some factors for that, right? That you maybe didn't see before. So now for 49, you factor this. Isn't that 7 times 7? There you go, right? Now, can you factor any of those numbers even further? No, because they're all primes, right? So you've reached the bottom of your tree now. Now, how is it that then you simplify? Well, remember, because it's a square root, remember that there's an invisible number as part of the root that exists right here. Now, we typically don't use it, all right? Or we usually don't see it unless it's something else, like a cube root, then you see the 3. Or a fourth root, then you see the 4. But because it's a square root, there's an invisible 2. What does that mean? You're looking for pairs of 2. You want the same number twice to show up in your factor tree. So lucky for us, 7 showed up twice. That means that number gets to go outside of the square root. Okay, that number goes outside of the square root. Okay, or another way to think about this is that the square root of 98 is also the square root of 49 times 2i. Okay, now because you know how to split these apart, you can then say, well, that's the same thing as square root of 49 times the square root of 2i. Okay, and now you know that the square root of 49 is 7. So now you end up with just 7. Square root of 2 can't be simplified any further, so then it's just square root of 2, and then you cannot do anything with the I besides just bring it down. So then this is the simplified version of the square root of 98. Okay, it's 7 times the square root of 2i. Okay, and then that ends up being your simplified expression. Okay, so that's one way, right? Kind of like algebraic, very specific. The shortcut is basically if you find the pair of numbers goes on the outside, right? So pair of numbers goes outside. If you don't have a buddy, like the 2, you box it, right? Because you're boxed in, you're in jail, you can't escape. You can only escape if you have a pair, all right? So the pair escapes, you put a 7 on the outside. The number that you box, that goes back inside the square root, okay? And because you had an I, right, on the outside, don't forget it, and you bring it down, okay? So there's the very systematic approach, kind of like algebraic, and then there's like the shortcut, okay? So whichever one you feel more comfortable with, I'm okay with that. Okay. All right. So again, let me know if there's any questions on that, and I can always come back to it. Okay. Let's move on here to another example. All right. So let's say, for example, we have let's try the square root of negative 48. Okay. So first thing, remove the I from the inside, right? So you want to break this up. Square root of negative 1 times 48. That then becomes square root of 48 times square root of negative 1. Okay. That then allows you to rewrite this as square root of 48i. Okay. So notice, really, in order to get from square root of negative 48 to square root of 48i, you basically eliminate the negative and you write the I on the outside, right? That's kind of the shortcut, okay? Rather than going through the 2 other steps that I did, I'm showing you the long way first, but eventually I want you to just make that transition of, if it's a negative on the inside, well, let me change it positive, but if I change it positive, now I have to put the imaginary out there on the outside, okay? Now, for square root of 48, again, that's not a number that we know the square root of, so we got to do a factor tree. Let's go factor tree. Okay, this one I want to show you how I approach the shortcut, okay? So I know that 48, I could easily think of that as like a perfect square and something else, but what if you can't? Let's say, for example, you think of 4 times 12 instead. Now, for 12, not fully factored, okay? I don't want to factor the 4 down because I know that 12, I can factor it using something that has a 4, right? So I can factor this as 4 times 3, okay? Because I've already broken down the 12 and the 48, I'm going to cross those out because I'm basically I just want to see what numbers are still left, okay? Now, I see a pair, right? I see a pair of 4s. So because this pair of 4s exists, I can circle them, right? So they don't have to be attached to the same branch. They can be separate, right? But as long as I haven't factored it any further, I can still use it. So now I can use 4 and 4. Because those numbers are the pair, then they go outside of the square root, right? Now that's a whole number 4. What was left over? The 3. I can box the 3 because 3 is prime, and you can't factor 3 down any further. It's going to be 3 times 1, so it just keeps repeating. It's going to be an endless cycle. So you leave the prime number alone. Because it's alone, doesn't have a buddy to help him escape. You want to think of the square root as like a jail, okay? So that becomes square root of 3. So now you drop the last thing, which is the I. Okay. Now, more formally, you could have also thought as the square root of 48 I is the same thing as the product of square root of 16 times 3. Okay, that's another way to think about it. All right, if you had seen that. Okay, now why is that valuable? Because when you take the square root of 48 as 16 and 3, it's square root of 16 times square root of 3, and then you have your I on the outside. Well, square root of 16 is a 4, right? That's why the 4 gets to come out to the outside. That's where it shows up. Okay, and then you just drop your square root of 3 and your I. Okay, so you see the two ways to do it. One is the shortcut, and then the other one shows you the math behind the shortcut. Okay, that's basically it. Okay, so how are we doing there? Okay. All right. Okay, so two examples kind of similar to each other. Let's move on now. Let's move on a little bit more complex type of problem. Okay, so now what happens when we start to combine the things that we know, right? So what if instead of having just one, now we have two? What if we have a product of two imaginary numbers, right? What are we going to do? So for example 4, let's start with the square root of -9 times the square root of -25. Okay, so now is the time where we can start using those shortcuts, right? We can use those shortcuts because we know certain things. I want to turn square root of -9, I want to turn that into imaginary number. How do I do that? Well, because I want to get that negative out of there, it's got to become square root of 9 with the I outside, okay? So when you have a product, okay, when you have a product, you may have been tempted to multiply the two numbers on the inside, okay? But that's not the correct way to do it. If you have a negative number inside of the square root, you convert to imaginary first, okay? So make a note. Convert okay, you convert it to imaginary first, and I'm going to show you why. Okay, I'm going to go through it correctly first, but then I'm going to show you what would have happened had you not converted to the imaginary. You'll see what happens. Okay, so now that means that is the product times, now I have the square root of 25i. Okay, now that the i's are outside, now I can go ahead and take the square roots of 9 and the square root of 25. Okay, we know what those are. The square root of 9 is 3, so we get 3i. The square root of 25 is 5i. Okay, now I still have that product I have to deal with. Now, 3 times 5, you can multiply together. Those are whole numbers. That gives you the 15. Okay, now you still have to multiply I times I. You want to think of I as a variable, right? So what if it was x, like x times x squared, right? Well, in this case, it's I times I, so it's I squared. Okay, now this goes back to what we looked at before, right? What is I squared, right? You got to know those two things. You got to know what I is equal to. You got to know that I is equal to the square root of -1, and you got to know what I squared is, because there's a lot of times you're going to have to make the conversion from I squared. You're going to have to convert it back. So what does this mean? This means 15 times, instead of I squared, that's a -1. So in reality, what's your answer? It's 15. I'm sorry, -15. Okay, so the simplified expression is -15. All right. Now, what would have happened, right, if you would have multiplied first, right? What if you would have taken -9 times -25 and you multiply those two things first? Let's talk about it. If that were to happen, I'm going to do it in red so you know that this is the wrong thing to do. If you multiply them first, before converting them to I, what do you get? Well, 9 times 25, that's going to be 225, okay? Negative times negative becomes positive, right? Negative times negative becomes positive. So you end up with the square root of 225. Okay? And then, right, you might think, okay, I think I could take the square root of that. You take the square root of 225. Because it's a positive, what are you going to give me? You're going to give me the positive of it. Okay? Do you see why it's the wrong way to do it? You get the wrong number. You get 15 instead of negative 15. You have to treat the I first. Okay? That's why. This is correct. And then this is incorrect. Okay? So don't fall into the trap. I first. I first. I first. Then you deal with whatever comes next. All right? So that's the lesson there. Any questions on that? We're good? Okay. All right. Let me add a couple more boxes here. If you still have space, feel free to keep working on the first page. If not, you can flip over to the next page. Let me just go ahead and... All right, hold on. I'm having problems here. Give me a sec. Okay. Okay, so let's try something else here. All right. Other things that are unique about imaginary numbers. Let's take a look at example 5. So let's say, for example, you are given this, right? You have this not irrational. You have this imaginary number, but you have an imaginary that's in the denominator, okay? Now the convention is, remember what the imaginary number looks like. It needs to be bi, which means I has to be part of the numerator. It cannot be part of the denominator, okay? Well, how do you get rid of it then? Okay, well, it very much like trying to get a fraction to have like a common denominator. The way to get rid of something in the denominator is to multiply by the imaginary number that's in the denominator. Okay, so it seems kind of strange, but here's what you do. You're going to go ahead and multiply the top and the bottom by 5i. Okay, notice how this 5i that I'm multiplying by is the denominator that was already there. Right? So I just take it, I multiply the top and the bottom by that. And here's what it does for you, okay? Because you're multiplying by 5i over 5i, isn't that the same thing as multiplying by 1? Right? 5 divided by 5 and I divided by I, that gets you back to 1. So why does it work? Because now 4 times 5i is 20i, but in your denominator, 5 times 5, that's 25, and I times I is I squared. Okay? Now, here's what you know about I squared. You know that I squared is -1. So then instead, Now what you have is 20i all over 25i squared, which is negative 1. Let me erase this. So now what you've done is, by doing that, you've allowed the I to now move up into the numerator, and in the denominator, you've eliminated the i's, because I times I gets you back to I squared, which is negative 1. So now all you have is 20i all over negative 25, right? I in the denominator is gone. That's what you want. You don't want to leave an answer with I in the denominator. So we call this process rationalizing, okay? Rationalizing, because typically you do it when the square root is in the denominator, but in this case we don't have a square root, right? But it's still that same process of rationalizing, okay? So we're doing so to get the I back into the numerator. Now 20 over 25, you can simplify that, right? 20 over 25, you divide top and bottom by 5, so you're going to end up here with negative 4 over 5i. Okay. Actually, the negative splits it right in the middle, okay? So negative 4 over 5i. And then that's okay. That's an okay number to have, all right? So that's what you do in that scenario. Okay, let's take a look at the next one. Okay, so I got 10 over square root of negative 5. Now, this goes back to that very first lesson, right, about what to do when you have a negative inside the square root. You convert back to the imaginary first, right? You want to get the I out in play, okay? So convert here into 10 over, now this is still going to leave you with a square root of 5. The only difference is that now the I is on the outside, okay? All right, now you have a problem very much like what you had in example 5, right? You had the I in the denominator, which you do not want. So guess what you're going to have to multiply the top and the bottom by, right? What is that denominator currently? That's what you multiply by, okay? So you're going to multiply by top and bottom by the square root of 5i all over square root of 5i. All right, so now let's see what happens. Okay, in the numerator, 10 is outside, 5 is inside. You cannot multiply the 10 and the 5 together. They have to stay separate. So 10 stays outside. Square root of 5 and I. Sorry. Then in the denominator, okay, check it out. I can multiply square root of 5 times square root of 5. That's going to give me the square root of 25. Okay. I can also multiply the I times the I together, and that's how I get I squared. Okay. Now it looks a little messy, but in the denominator especially, I can clean a lot of that up. So now here's what we end up with. I get 10 times the square root of 5i. Nothing in the numerator can be cleaned up. All right, we leave it like that. But in the denominator, now we know square root of 25. Well, that's just 5, isn't it? And then I squared, isn't that negative 1? So now we can clean up a little bit more, right? And what's the good news? The good news is that now I is in the numerator. That's where it's supposed to be. That's where we want it, okay? So then finally here, let's clean up. So we get 10 square root of 5 times I all over, this becomes negative 5. All right. Well, now take a look. Remember that these are products. This is 10 times square root of 5 times I. So I can at least simplify the 10 with the 5 that's in the denominator. Okay? I can go ahead and do that. So this gives me square root of 10 divided by negative 5. That's going to give us negative 2. Okay, 10 divided by negative 5 is negative 2. Everything else stays in the numerator. Okay, and that right there would be my simplified version of that value. Okay, negative 2 times square root of 5i. Okay, how are we doing so far? Making sense? Okay, let me know. Okay, all right. So now next thing, let's do a few more. We might do two more. Okay, so let me draw another line here. Okay, let's take a look at something a little more complex. Okay, so example 7. Okay, so example 7, we got square root of 24 all over 7i square root of 2. Okay, so we got some complexity here. Again, let's start with what we've usually been doing, which is to go ahead and take, if I have an I in the denominator, then I got to multiply the denominator to the top and to the bottom. Okay, we got to go through that rationalizing process. Okay, so again here, I'm going to multiply by 7i square root of 2, 7i square root of 2. Okay, so now let's focus on denominator first, because that's where we get to clean up most of it. Okay, 7 times 7, that's 49. Okay, so we get 49. I times I, that's going to be I squared. And then square root of 2 times square root of 2, remember, when they're both inside the square roots, you can multiply the inside numbers together. So then we get the square root of 4. All right. Now on the numerator, okay, I can go ahead and multiply the 24 with the 2. So I still get 7i square root of, in this case now 40, that's going to be 24 times 2 is 48. Okay. So now let's clean up denominator first here, okay, because I can see that that's where a lot of stuff is going to help us eliminate. So 49 still stays, times I squared. Remember, I squared becomes -1. So you get -1 times, what's the square root of 4? That's 2. Okay, so now that's what you have as your denominator. Your numerator, we're going to keep it the same for now, because then later we're going to try to do a factor tree on 48 and clean that up. Okay, so for now, here's what we got. Denominator, we can clean it up. 49 times 2, that's going to give us 98. 98 times -1, -98. All right, so now, let's approach the numerator, right? So let's do a little scratch work over here, because the important part is to break down that 48 into a factor tree. We did one similar to it already, okay? So it shouldn't be too bad. So 48 factor tree, this could be 16 times 3, and because 16 is 4 times 4, right? Then we can rewrite the square root of 48 as 4 square root of 3, okay? So now what I have in the numerator is 7 times I times 4 square root 3. Well, I'm allowed to multiply whole numbers together. So I have 7 times 4 that I can multiply together right now. And that gives me 28 square root of 3. Now I'm going to write the I at the end finally. Okay, all over -98. Okay, I'm almost done. All right, now you got to think of 28 and 98 as a fraction that can be simplified. Okay, because square root of 3 and I, you're done. You can't touch them anymore. But 28 and 48, there's a possibility there that you can reduce it. Okay, so if I reduce 28 and 98 by a certain number, right, think about what I could get. If I divide the top by 7, right? If I divide the top by 7, that gets me to 4. If I divide the bottom by 7, that gets me 14, I believe. 7, 28, yeah. Okay, so now I've reduced it. Now what I really have is 4 root 3I all over negative 14. I'll be right back. Give me a second. Okay, so now last thing, you see the 4 and the 14, you can reduce those one more time, right? So then that becomes 2, that becomes 7. So now what you're ending up with is going to be negative 2 over 7 with a square root of 3I in your denominator. I'm sorry, in your numerator. Okay. And then that's it. Okay, so that's the simplified version of your expression. Okay. Any questions so far? How we doing? Let me know. Okay. All right. Well, if there's no questions, then that's pretty much it. So the homework is there. This all makes sense. Good. All right. Good to hear. Good to hear. So the homework is up. It's only the first 20. Okay. So there's a couple of examples built into the homework. So you'll see like example 1, then there's a couple of practice problems, and there's example 2, then a couple more. Stop at 20. Okay. I don't want you to go any further because we haven't covered the rest. Okay. So leave it at that. And then I'll see you guys next week. Okay. So I usually don't see you tomorrow. So enjoy your weekend, stress free. Hopefully you don't have too much to take care of. And again, homework, just make sure you're kind of staying on top of it. I know that I'm not going to check it, obviously. So Monday, we'll probably go back to Edulastic. If we don't, then I'll send you something on Sunday night to let you know what we're going to do, whether we're going to do like a live stream video or if we're going to do Edulastic. Okay, so just stay posted. Make sure you keep checking your Schoology, and then I'll let you know what's going on. Okay, so again, if there's anything further, feel free to message me. Watch the video over again at your own pace. Make sure that you're kind of understanding what's going on and where everything comes from. Okay. All right, guys. Well, I'm gonna sign off then, and I'll see you guys soon. Okay. Take care.